Hello everybody out there in YouTube land. Welcome back to my workbench, and have a couple things trying to catch up with all the mail and stuff that came in here, all the stuff I've ordered, and I thought maybe I'd share that with you at this quick video, but really that's only just the first little part. But really the last thing I'm going to show you is what this video is actually going to be about. So let's start out with the other stuff first that's come in. And the first thing I'll show you is these two things right here. And as you can see, there are a couple of little circuit boards. Okay, so you get off on a tangent. The phone rings, it's a tech support call, and an hour later, I'm back trying to figure out what I just said last. Anyways, I think what I was saying is that the first item here is a little amplifier kit that I got, and it's very inexpensive, and hopefully I'll be able to pop up some addresses or something, but this is an eBay purchase. They can be bought for, I don't know, 10-15 bucks online, which I thought was a really good deal. Comes with some rudimentary heat sinks, comes with all the capacitors. They're no-name weird capacitors, but if you notice, they're 105 degree caps, so what the heck. And then these are the equivalent of a 2N3055 115 watt transistor. There's 4 of them. It's a stereo amp, supposedly class A stereo, and supposedly somewhere between 15 and 20 watts per channel, something like that. It looked really interesting, and for that, for the cheap price, I couldn't go wrong. I mean, I couldn't pass it up. I got 2 different iterations of it from 2 different dealers, but they both look very similar. They're the same pretty much design. This is a much heavier, better quality circuit board than that other one. But everything else seems to be, the heat sinks are wrapped up in this one. It's a little fancier, but for the most part, I think it's all the same. Same capacitors, all that. But we're definitely going to do a project video on these and build them up and see how they sound. And really, I'm hoping if this works out, this is going to end up being one of my my bench sound system that I'll test preamps and tuners and things with. I think that will be pretty cool. And I have a nice little tube preamp kit that I'm going to build with it, and should be a fun project, so I hope you guys will join me on that one when we get to it. Alright, next thing we got was needed to get some new attenuators, so I got some attenuators for my oscilloscope and my signal generators, and there's a 20 dB, a 6 dB, a 10 dB, and this one should be a 3 dB. And then, last but not least, is a DC blocker. And these are nice because these will kind of protect your test equipment from any kind of DC on the test points, or on the inputs. So, I needed those. I mean, I have some homemade ones I've been using, but these were pretty good price, so I picked them up, and we're going to try them out. The next thing we have is a couple of little, I've been seeing these, they're like $5 or $6 with free shipping, and they're just little AM, FM radio kits. If you take a look, real small. Of course, made out of fine china. And but again, for a beginner's project, anybody who's getting into this, it might be pretty fun. So you can see here, it all comes, with a little Mylar speaker, and comes with an antenna, AM, FM television. So 2-band radio. Comes with the little circuit board and with the dial. You can see that. And you can see they try to make it look like Panasonic, but that is not Panasonic. I don't know. PN-Sonic? Pan-Sonic? I don't know. But you gotta laugh. But hey, you know what? You know, for a beginning project and for something that a little time waster, I'm actually looking forward to this. And I got a couple of them, again, for the $5 or whatever they cost. I mean, guys, if you, and girls, and all of you who are watching, if you want to get into electronics, especially like radio and things, these are great little projects to get into. And hopefully we can use this to be like a little springboard of how to align a simple radio like this when you don't have a lot of test equipment and stuff. So it might be a lot of fun. And here's another one. It's just a little different case. Blue instead of white, but it's the same principle, same kind of radio. So we'll build these and we'll have a lot of fun doing this. Next up, something I've been wanting to get for a while now. Maybe some of you already know this before I open it, but a Rubidium frequency standard. Now, if you want to know what these are, if you're not familiar with them, what this basically is a very, very stable, accurate signal generator, okay? And this one in particular has been set up to generate a 10 megahertz, and I mean 10.0000 all the way down within 1 part per million, 10 megahertz signal, okay? And these are used most often in cell phone towers and so forth as the reference frequency, but these also, you know, make a great reference frequency for things like over here when you have a spectrum analyzer, some of the higher end signal generators and oscilloscopes and so forth. Many of them on the rear of the device will have an input for a 10 megahertz standard frequency. And when you do that, it increases the accuracy of that test equipment by having that frequency standard in there. Now, all of these test equipment that I showed you, like especially the spectrum analyzer, they all have internal frequency standards that they use, like a reference frequency. A lot of them are crystal controlled. For instance, the one in the spectrum analyzer over here, which my light's in the way right now, it actually has a pretty nice frequency standard, and you'll see. Okay, I've got most of this in the shot, I think, and I have everything unpackaged. And basically there's three main parts to all of this, okay? The first part is the base unit, okay? So this is the basic frequency counter, all right? Then two options that you can buy separately, and this is the kit that's only, you know, that's the $75 or $72, and again, I'll give you the link to all this kit. Then for an additional charge, you can add a power meter module, and it goes in, you know, in the faceplate, the power meter, okay? And there's also a space for a second module, which is your B channel module, okay? And that's the one that will check the high frequency. So there's a low frequency, a high frequency, and a power meter, if you get all the options. And then there are two different power meters, one for lower frequencies and one for higher frequencies, which I have the other one on order as well. And so I've got two different modules I can swap out. Now here is the basic kit. As you can see, here's all the components, and from what I can tell, these are should be fairly decent components. 105 degree capacitors, you know, 10% pretty decent resistors. I mean, all the components look pretty good. It has a blue, here we go, display, a really high resolution display, that OLED display, which is nice. So looks like it's going to be relatively simple to assemble. It comes with a full assembly and user's manual, which, you know, color, very nice. Okay, and it comes with a CD-ROM, and it's got the drivers, the software, and all the manuals on this CD-ROM. So once this is done, we can actually connect this to the computer up here, and there's all kinds of additional tests that you can do with this piece of test equipment. So if this all works, you know, for my $200 investment, I'm going to be able to do quite a bit of things with this one little tiny, and when it's all done, you know, here's all the bigger that it is. I mean, this is it. Very simple, pretty amazing. So the first thing I'm going to do is read through the manual. We're going to get our little board holder set up here, and we're going to get it all assembled. I will spare you the boredom of watching me solder a bunch of parts together. I think we've all seen kits being assembled before. If there are any interesting things along the way during the assembly, I'll stop and we'll get it here onto the video, and then you know, once we're ready to put everything together, we'll come back and then we'll test it out. Alright. So looking through the manual, you can see that the first thing they give is you a little description. So the first thing this thing is, like I said, it's a frequency counter, and it ranges from megahertz resolution with reciprocal counting algorithms to 5.8 gigahertz. Now, this module, if we use it, when we use it, it will go up to 5 gigahertz, but I believe it only goes down to 10 megahertz. So if you want to count low frequency, like in the AM or shortwave bands, there's another module that I have on order. It just hasn't come in yet, and it starts from DC and goes all the way up to about 500 megahertz. And we can swap those modules out if we need to, I believe, in order to have the two different functions. So, you know, you can configure this again when you order it however you want, but I have the high frequency module with this, but it also has a lower frequency. There's a pulse counter, and you can use that for counting RPMs and things like that with different inputs. You have a power meter, and it reads, I'm sorry, this one does do, the frequency counter does do the full spectrum. I got a little confused here. It's the power meter that has two different modules. The module that I have is the 10 megahertz to 8 gigahertz. The other one that's on order is DC to 500 megahertz. So when you want to use your power meter, you have to have the right one in there. So I'll probably, you know, use the DC to 500 megahertz a lot, but if we're working with cellular or we're working for Wi-Fi, things like that, this will be able to measure power all the way up into the Wi-Fi range, and our frequency counter should be able to count all the way up into the Wi-Fi range. And now you can see why I'm kind of interested in this product. To get something that you know, with a graphical, you know, computer interface and all that for that price, I mean, I've seen these in tens of thousands of dollars sometimes. So if this works, you know, it's pretty amazing. Has a USB interface, and it can measure frequency, period, RPM, okay, all kinds of things. So very, very, very good piece of test equipment. Looking at the specifications, channel A is 2 hertz to 80 megahertz, okay, and you can see that the sensitivity is pretty good on these. Alright. Channel B takes you from 70 megahertz to 5.8. So you have two different inputs for two different ranges, and that's for frequency. The thing that's pretty amazing are some of the accuracies we can get. Your time base on this thing is 50 parts per million for the standard, and then when we have the TCXO option, it goes down to 1 part per million accuracy, which I do have that option on this. And it can be calibrated. I mean, something this small to be this accurate for this price is almost too good to be true. I mean, in my opinion, I don't know. So the bottom line is, you know, when you look at this thing, it can read power. And again, this is not something you're going to hook up to your HF linear amplifier, obviously. It's going to read from negative 55 dBm up to plus 30 dBm, okay? It's really meant to be able to measure things like, again, you know, cellular, Wi-Fi, you know, low-powered transmitters and things like that, which is great for what I'm doing. I mean, I have a big power meter if I want to read watts and so forth for, you know, a big HF transmitter or something. This is not for that. This is for delicate high-frequency gear, is really what it's centered around. Okay, so it's got a dot matrix LCD, which is really nice, and you know, pretty simple. So we're going to put this thing together and see if it lives up to the to what it says. Again, I have really high hopes for this, and I hope it works out. So I'm going to start assembling. Okay, so the first thing I notice here is, if you look at the silk screening on this, it tells you the values of the components. You know, not the values of the components, but the name, the identifier, like, you know, R11, R2, whatever, C1. But it does not tell you the value of the component. In order to do that, you have to go into the manual, as you can see here, and it has the bill of materials, and it tells you each component's label and what value that is. So for instance, when you come across C3, you would have to look it up in this chart, and you find that C3 is a 100 nanofarad capacitor. Also, they have a little more, as you can see, a little more accurate placement diagram of the components with reference to the board, in case you can't read the silk screening. So you really kind of got to go back and forth to figure out what component goes where. I mean, it's very clearly marked, but it's just a little bit of a, you know, a little bit of a chore to look this all up. If you have bad eyesight, things are really tiny on here, and that's kind of why I use this. I don't know if it's ever been in the image or not, but I have a actual, you know, one of these lights with the magnifying, and you know, if I put it down in here, if I go down, you can actually see, kind of makes it a lot easier to work, you know. So I'll get this up at eye level and you know, kind of focus on it, and then hopefully we should have a little bit of better vision here doing this. But normally I don't use the magnifying glass a whole lot, but on something like this we may need to resort to that, as you can see. So the task begins, you see, with the process I have to go through looking this up and then locating the component in this pile of parts. And so this is going to take a little bit of time, but I'm just going to take as much time as it takes to make this thing perfect. Also, I'm going to switch out my tips on my soldering gun, or the pencil, and I'm going to go with one of these little curved tips. You can see here. It will be a lot easier to get in here to some of these than the chisel tip that I normally use. So just kind of little things to keep in mind for doing this job. Okay, the deed is done. And first of all, we'll go and take a look at this manual, how it has you put this together. First of all, it gives you this picture, and you really want to study this before you start putting this together, because there's a lot going on here. Some components are on one side and some components are on the other side, and you got to make sure you get this all put together properly in the right configuration. Second of all, this is not an assembly job for a beginning electronics person. The soldering on this is very difficult. And when I say that, you know, people who do this for a living or who do this a lot won't have a problem. But you do want to make sure that you have the correct equipment before you do this. A cheap, you know, soldering pencil with a big tip is not going to work for you. You will need a temperature controlled iron, or you should use one, I recommend, and you're going to need some fairly fine tips. You know, I used this one for part of it. It's like a bent tip, you can see. And then I also used just a small pointed tip, and you can see there. And I really, that's the only way you're going to get in here. You can see some of these, how close together these components are. And you can see how close together these little pins and things are. And when you get on the other side, you can see. Now, contrary to what I believed, I didn't really look closely until I started assembling, but if you notice, this LCD module does not plug onto this board. They actually have you solder this pin array onto one side of the board. Then those pins protrude through the LCD board and you solder them in up here. So this is pretty much a permanent fixture on here once you put it on. So this should be the very last thing you put on, okay? Because you surely don't want to be taking this all back out to get to anything that's underneath there. Now, a couple of things about this kit that weren't so good. Number one, the only chip that came with a socket was this long one here. These four did not. So I got some good double wiper sockets, and I put them up on sockets. And the reason that I did that was, again, if I ever need to replace a chip, they're difficult to remove, and double difficult because you have to take this off to get to it. So hopefully it's permanent. Hopefully nothing will ever fail, but you want to make sure you do that properly. The other thing is, it did come with a little terminal here, screw terminals for your power. This is mounted inside of a case, and it goes from here to your power plug. So I opted to direct solder a good set of Teflon coated wires to it, just to eliminate any problems in the future. Okay, so that's the next thing. So far everything was manageable. These tactile switches are very flimsy, as you can see, very cheap quality. I would have much rather seen you know, panel mounted push button switches, a little better quality than that. They make mini ones that are a lot better, but that's okay, it'll work. Now for the not so good part, and this is the part that I was not happy with, and that is when you go to put this in its case and you go to put everything together, you got to kind of, you can see that first of all there's a big gap between your LCD and your panel. I mean, I can live with that, I guess. But the thing that's causing all of this, and you can see, it's these modules. They literally positioned these little connectors too far forward. And you can see it pushes these little boards until they just run into this faceplate, and it holds everything out. Look at the gap between the USB connector and the panel. It's huge. Just stupid. Why would you know, you get everything almost perfect where it's a nice kit, and then you do something like that. And you can see if I take these modules off, everything fits perfectly. You can see that this is flush, these are flush. It's perfect. So this is an epic fail. I mean, I can't recommend this product to anyone until these guys get this right, because again, when you look at this, you know, the average person that's going to put this together isn't going to have a machine shop and isn't going to want to cut up their faceplate to make this protrude through. I mean, it kind of, you have writing down here. I mean, if I cut into that, it's a shame, and it really upsets me, because this I was, you know, really looking forward to this. This was looked like a really good project. So I'm going to have to think about it, how I'm going to deal with that before we, you know, go too much further. But at least, even without the faceplate, we can put this together and power it up and test it and see if it works. So I'm going to do that first, and then we'll worry about the next problem later. I am going to contact the manufacturer and show them this and see if they have any recommendations. Maybe I put something together incorrectly. That's always a possibility. But you know, looking at the way they have this all put together, it really looks pretty similar to me. I mean, they have a little different oscillator there, but yeah, it's the same thing. So I don't know. Again, I don't know. We'll have to figure it out. So get some power to this and see how it works, and we'll be back. Okay, so I've read through the instructions, just a rough thing, and they want, for first initial power up, they want you to use that it's advisable to use a current limiting laboratory power supply set to 9 volts and 300 mA. So if you look up here at our laboratory power supply, let me move you here, hold on. You can see I have it set to 9 volts at 300 milliamps. So it's connected up, and when I hit the power enable on the power supply, this should come on. So let's see. Hey. Okay. Very good. Alright, so we have a power up, and I'm going to power it up one more time, and I want to see what it's saying here. So there you go, initialization. Tells you the 2 modules, you can see, and then it comes up and it's ready to go. So now we have our signal generator set to 15 megahertz, and I'm doing 500 millivolts peak to peak, and I have my sensitivity turned up all the way after I read the book, and this should show 15 megahertz. Pretty good, look at that. How about it, right out of the box. Now apparently this is adjustable, but this might be a good thing to test out our Rubidium frequency standard to calibrate it. So that might be a project later on after we do that. But for now, at least the main module seems to be working. We haven't tried these other 2, and I probably won't try them because they're just kind of precariously plugged in there. I probably won't try them until I get the faceplate mounted and get this mounted in the case. So everything works. Let's see. And there's your menu. And then this changes to frequency, period, and RPM. Okay. There you go. And then this changes between channel A and B. Supposedly, yep. Channel B, channel C, power meter, and should be back to channel A. So everything works. Before anything gets messed up, I'm probably just going to go ahead and put it together, put it in the case. Checking this 5-volt regulator. It's warm, but it's not, you know, I can hold my hand on it. So I think we're good. So next thing, let's get this mounted in the case, and I really don't know what I'm going to do about the faceplate, but we'll figure something out. Well, after some cutting and hacking, as you can see down here, which did not make me very happy, I was able to get this all to fit and to go in here, and actually it works really well. So let's connect our power cord to our power supply up here, and we'll see if this works. Let's clear. Let me clear some things out here. Okay, so if we take a look here, we have the Rubidium frequency standard plugged in, and I just have it, you know, clipped on to my power supply. And I have the frequency counter, and I'm plugged in just through this little jumper cable, you can see, from the frequency standard to the frequency counter. And as you can see right now, this is a 10 megahertz signal, and you can see right here we're pretty close to 10 megahertz. Now understand a couple things. In the instructions, the frequency counter here does not reach its maximum accuracy until it's been on and warming up for about 20 to 30 minutes. And likewise, the Rubidium frequency standard also does not get super accurate till it has been on for about 20 minutes or half an hour. They both have to kind of reach that happy ambient operating temperature. So if we take a look here, it's working pretty well. Now, a couple things I noticed about this is right here is your sensitivity adjustment, and I have it turned up to maximum. This counter does need a relatively high signal, such as, like, you know, a half a volt peak to peak, for it to be able to trigger. And that kind of is a little bit disappointing, because, you know, I was kind of hoping we could use this on, you know, some RF, you know, very low signal strength, but there are fixes for that. So for instance, you can very inexpensively purchase little devices like this online that are not very expensive. This is a really inexpensive one, and all they are is just a signal amplifier, and we can take those and we can put them in front of this, and that will amplify the RF to a level that the frequency counter can trigger on it. Also, we have these the power meter, and we have the high frequency counter. This one will go from DC to about 80 megahertz, and it's a 1 mega ohm input impedance. This one is a 50 ohm input impedance, and it will go from 10 megahertz up to about 5.8 gigahertz. So far, I've done some preliminary tests on these, and everything seems to work really, really well. I'm very, very pleased with it. Unfortunately, to be able to plug this into the USB, if you notice, this is a just a regular USB Type 2 male, and of course the plug that plugs into your computer is the same connector as this, and most connectors don't go, you know, they either have a micro USB on one side and then this on the other, or they have a, you know, male to female, or they have a like a printer plug, the square type plug on one end and this on the other. So I do not have a cable that has this connector on both ends. Okay, so I did order some, and they should be in this week, at which point then we can connect it to the computer and check the software out. So I'm going to probably put this little video on hold and not post it until I get the software running and so we can do some more testing on this. But so far, other than the manufacturing of the case, because these modules do not fit, they actually run into the front of the case. The spacing is incorrect. With the exception of that, this is an excellent kit, and I recommend it. I would also recommend possibly building, if you have the means to do it, building your own case. This is a really flimsy kind of case. It's kind of awkward to put together. It's in two halves that slide together over top of those circuit boards. Just not the greatest thing on earth. As far as a power supply, this requires a 9-volt power supply at 300 milliamps, or a 9-volt 1 amp power supply will be great. And just a wall wart that has a clean output. I certainly would not, I would be careful with the really cheap ones that you don't get any interference that could interfere with this, but that's really all you need for that. And once you do that, that's all you need to run this thing. So until I get the my cable in that I ordered, I'm going to put this video on hold, but so far I really like what I'm seeing. As I showed you before, there's your options, okay, your menu. You can switch between what type of tests you want the port to do. So for instance, it starts out at frequency, and so this port's a frequency counter. If I hit it again, it's RPM, so you could actually put, like, an RPM, and then period. You can check period for like pulses. So this thing is really versatile what it can do. This little button that's kind of hard to get to in the middle here actually is what toggles between the 3 ports. So you can go from port 1, that's toggles between A and C, which is this one. Alright. Your power port, which is to the left, and the button is kind of futchery there. And then channel B, and there's your frequency meter, your high frequency meter here, and it can take plus 24 dBm or 10 volt peak to peak max. And on the low frequency counter, it'll take up to 50 volts peak to peak, which is pretty good. So anyways, there is in a nutshell what it does. There's a lot more I think that we can do once we get the software loaded up, and so I'll get that cable and then we'll be back. But for right now, we're going to call this one on hold for the moment. Okay, back on the frequency counter / power meter, and you can see it's connected to our frequency standard, and I'm using this software, which actually is pretty intuitive. If you look, it has the actual counter. You can switch between the channels right from here. You can change frequency period or RPMs. You can change it from comma to decimal mode, so that how you want it to display. The other nice thing is you can actually get a graph of the consistency of the frequency. You can save these images. There's all kinds of different things. You have your statistics with min, max, and average. So this is going to be some really good software, and this is going to be a really good frequency counter. I give this thing 2 thumbs up. I give the case a thumbs down, but the actual device itself is fantastic. I'm very happy with it. So we will be using this on future videos. So I hope you like this on this little frequency counter project, and hope to see you in the next videos. thank you once again for watching, and thank you for all your kind words, and lots more to come.